Ever look up at a clear noon sky and wonder why it wears bright blue, and then return at sunset to see it painted in red and orange? The sun itself never actually changes color. So what is the atmosphere doing to the light? A common guess is that the sky reflects the oceans below, but the sky is just as blue over dry deserts and mountain peaks. Another guess is that the sun cools down at night and turns red. Yet the sun is a constant blazing sphere of plasma. The real answer is hiding inside the light itself. Sunlight may look white, but it is actually a mixed bag of colors. A prism can split this white light into a rainbow. This rainbow is called the visible spectrum. Each color in the spectrum travels as a wave of light. The distance between wave peaks is called the wavelength. Red light has the longest wavelength of the visible colors. Blue light has one of the shortest wavelengths. Now let us bring in the atmosphere. Earth is wrapped in a blanket of air made mostly of nitrogen and oxygen. These gas molecules are incredibly tiny, much smaller than the wavelength of light. When sunlight enters the atmosphere, it collides with these molecules. This collision is called scattering. In the 19th century, a physicist named Lord Rayleigh figured out the rules of this scattering. The rule is now called Rayleigh scattering. Here is the key part. Shorter wavelengths scatter far more than longer ones. Specifically, blue light scatters about 10 times more than red light. To picture this, imagine sunlight as a highway full of vehicles. Blue light waves are tiny bumper cars zipping around. Red light waves are heavy semi-trucks rolling forward. The air molecules are like rough potholes scattered across the road. The heavy trucks roll straight over the potholes, but the tiny bumper cars hit the potholes and bounce off in every direction. This is exactly what happens to sunlight in the sky. Blue light scatters sideways in all directions. Some of this scattered blue light travels down into our eyes. That is why the sky looks blue in every direction at noon. Wait, you might ask, why not violet? Violet light has an even shorter wavelength and scatters more than blue. But our eyes are much more sensitive to blue than to violet. Plus, the sun emits less violet light to begin with. So the winner of the daytime sky is blue. Now let us move the sun to the horizon. At sunset, the sun sits low in the sky. Light from the sun now enters the atmosphere at a shallow angle. Think of the light as a slide at the playground. The slide is short and steep at noon when the sun is overhead. The slide becomes long and flat at sunset. This longer path means the light must pass through much more air. In fact, it passes through roughly 30 times more atmosphere than at noon. All that extra air acts like a giant strainer. The strainer catches the bouncing blue cars and scatters them away. By the time the light reaches your eyes, almost all the blue is gone. Only the long red and orange waves slip through the strainer. These long waves travel in a straight line right to your eyes. That is why the sun and the sky near it turn fiery red. The same physics also paints clouds pink and orange. Clouds are made of water droplets, which scatter all colors equally. So the color you see is just whatever the atmosphere leaves behind. On a clear sunset, that leftover color is red or orange. On a polluted or dusty day, the sun can look even deeper red. Extra particles scatter away even more of the yellow light, leaving only the deepest red to reach your eyes. The sky directly overhead at sunset is still blue, because the long scattered blue light from the rest of the sky still reaches you. The transition from blue to red happens gradually as the sun dips lower. Every minute adds more air to the light path. Engineers ran into the same physics when building the modern internet. Fiber optic cables carry data using pulses of light through glass. The silica glass inside these cables scatters short wavelengths just like air does. If engineers used visible blue light, the signal would scatter and weaken over long distances. To prevent this, they chose a special long wavelength infrared light. This light is often called the 1550 nanometer band. It behaves like the heavy semi-truck on the highway. It rolls through the glass without scattering away. That is why an undersea cable can carry a signal across an entire ocean. Without Rayleigh scattering, long-distance communication would be far less efficient. Doctors use the same trick with medical lasers. Long-wavelength infrared can pass deeper into human tissue. Astronomers also design telescopes to avoid scattering. Space telescopes orbit above the atmosphere to skip the blue sky entirely. The Hubble Space Telescope sees the universe without Rayleigh scattering in the way. Even painters and photographers use this knowledge. Knowing the color of light helps them set white balance on a camera. It explains why a flash photo indoors often looks too orange or too blue. The same physics powers anti-counterfeit ink in banknotes. Tiny particles inside the ink scatter specific colors when held to the light. Let us recap the journey of a single beam of sunlight. It starts as a mix of every color in the rainbow. When it hits the atmosphere, blue scatters in every direction. At noon, the short path fills the sky with scattered blue. At sunset, the long path filters out all the blue. What remains is a stream of red and orange waves. The same rule that paints the sky also guides fiber optic cables. Long wavelengths travel far. Short wavelengths scatter away. The sun never changed color at all. It was the air above you doing all the work. The next time you watch a sunset, take a moment. You are watching a physics lesson in real time. Light, air, and a bit of scattering are writing the colors of the world. That is the simple mechanics behind the blue sky and red sunset. A clear sky is not painted blue. It is simply the color of scattered light reaching your eyes. Thank you for watching this video. Let me know in the comments if you liked it. Don't forget to like and subscribe for more.